Welcome to Data Analytics from Theory to Practice. Today we'll be talking about K nearest neighborhood. You're welcome. I hope you have subscribed to the channel so that you can get more videos. Now we're talking about K nearest neighborhood. K nearest neighborhood, as the name implies, neighbors. Algorithm, you know that it's a simple algorithm, intuitive and powerful, supervised learning techniques used for both classification and regression tasks. K nearest neighborhood makes prediction based on the closeness or similarity of point. Talking about data points, you look at the prediction will be made based on the closeness or similarity of data point. Then, when given a new unseen data point, it looks like the K nearest data point, that is the neighbors, in the training set and makes a decision based on those neighbors. Now let's look at a key concept. Now when we say K, this is a number of neighbors to consider. Example is considering K equals to 3. What it means is that the algorithm looks at the 3 closest data points to the test set. Now, these are the common distance metrics used to measure the distance between points. The first one is Euclidean distance, which is the commonest of all. And let's say we have point P and Q. So the distance between them is given as thus: the summation square root of xi minus y all squared. The Manhattan distance. Now we have distance PQ. Again, Manhattan distance is the summation of absolute value of xi minus yi. Then Minkowski distance of order P. So the distance PQ is equal to the formula we have there. Summations, I goes from 1 to n. The absolute value of xi minus yi raised by p. Then everything raised by 1 over p. That is pth roots. Now, the special case of this p, when p is equal to 1, it goes back to Euclidean distance, ED. When p is equal to 2, it goes back to Manhattan distance. By the time we substitute, you see what it means. Then these measure how far 2 points are from each other in feature space. All these measures. Now let's look at classification and regression example. Now if you have a case of classification, the class most common among the K neighbors becomes the predicted class. For example, if 2 out of 3 neighbors are class A, then the new point is classified as A. That is a majority vote, kind of. Now in the case of regression, the predicted value is typically the average of the values of the K nearest neighbors. In this video, we're going to be looking at a classification. Then the next video, we're going to be looking at a regression example. Now let's look at the algorithm. The algorithm goes thus: let K equals to 3. The nearness is determined by Euclidean distance or Manhattan distance or Minkowski distance, whichever one is applicable. Now let's look at the algorithm. Determine K. You first choose what K you want to use. K's nearest neighbors, whether K equals to 1, or you want to consider K equals to 2, K equals to 3, K equals to 4, up to whatever value of K you want to choose. Now, next thing is to estimate the distance between the unseen data and the training samples. Talking about the test data, that's the unseen one. The unseen one that I want to use to predict, actually, I want to use to predict. So now we sort the distance, then collect the classes of the top 3 in the case of K equals to 3. then choose the majority one. And when you look at a typical example on the right hand side, is an example of the distance between 2 points P1 and P2, and the formula following Euclidean distance is displayed. Now let's look at an example, what it looks like. The typical example of k nearest neighbors. Now look at this star, this orange star on the left hand side looks at all this cross represent one class, then the blue represent another class. Then the red dot is the test point. Now, looking at this, look at this dotted circle, the lines that we are seeing that makes a circle, it actually shows that the three blue colors are the closest point to the test point. So the distance was actually measured using either Euclidean, Manhattan, or Minkowski distance. So whatever approach you use to measure the distance, so it shows that the blue color circles actually they are the closest. So they are the three closest. So it can be classed, it will be classified as what? As blue. So the algorithm will classify the red test point belonging to blue class. That is it. Assuming we have two blue class, two blue and one orange cross. That is, there's no classification because you cannot just classify as red and blue at the same time. It has to be one classification. So, but in this case, we have the classification to be three, to be blue, being the three blue circles are clustered around the red test point. Now let's look at a numerical example. Now let's look at this table. The table below contains data n equals to 5, not 6, observations of a three-dimensional input. Now we have x be x1, x2, x3. Then we transpose that, what that means. And a qualitative output y, the color green, the color red or yellow, actually, not green, red or yellow. Now, consider the first four rows of a table as training data, while leaving the remaining one row as a test data, that is the fifth row. Use k nearest neighbors with k equals to 1, 2, 3, 4 based on Euclidean distance to classify the test data point and compare against their blue label. Which k would you recommend? Provide justification for your answer. Now let's look at it. The solution. Now what we are going to do first is we have I to be 1, 2, 3, and 4, while the fifth is represent the test point. So we have our Euclidean distance as square root of summation xi minus yi squared. Then what we do, our xi there, x1, looking at it, for point 1, for the distance 1, we have 0 minus 1, picking the first one there, 0, 1, 0, as against the fifth one minus 1, 0, 1. So we now say 0 minus 1, that becomes plus, we square it. 1 minus 1, we square it. 0 minus 0, we square it. By the time we look at that, that is, the distance is 1. Then we go to the D2, 1 minus squared, 0 minus 1 squared, 0 minus 0 squared. We have 4. 4 plus 0 equals to root 5. Then we go to the third one. We follow that pattern. This is we have the distance. The last one is 8, not 6, as we can see in the table. Right. Now let's look at the interpretation of this. Looking at for k equals to 1, we know that k equals to 1 classify it as red. And red is the closest, is a minimum distance. Is the closest, so we have red to be what? It's classified as 1. Then for k equals to 2, we also see that root 5 is also a minimum value distance there, which classifies as 2. So that means 2 closest points, 2 red are classified, and it is classified as red. Then we go to the next one. for k equals to 3, the least 3 points are red. So they have 3 closest points. Now we'll now go to k equals to 4. 4 closest points, one is blue, the other is red. Absolutely. That means it classified correctly for what? K equals to 1, k equals to 2, and k equals to 3. Right. So you only classify correctly for the 3. But when it comes to k equals to 4, not classified. It's neither blue nor red. In that case, what we have, the conclusion is that this algorithm classified correctly for k equals to 1, k equals to 2, k equals to 3, but when it gets to k equals to 4, it failed. So it failed to classify as red. So this is how we do classification problem when it comes to k nearest neighborhood. And I hope you have been able to get something from this. Any question you are given when it comes to classification problem, this is how it is done. Thank you for watching. Don't forget to subscribe for more videos. The next is going to be regression, k nearest neighborhood using regression problem. Thank you.